All right, thank you very much. I am going to be talking to you about fungi, and I guess you also have the pleasure of a slightly tipsy speaker today because I got my I got my bachelor's degree in 1996, so I'm up way past my bedtime, and that chamomile just kind of pushed me over the edge. So, so here I am. I'm going to be asking you to think about this question today. Should we be watching over the fungi? And I don't really mean should we be watching over the fungi because they're going to attack us. Some of you may think that the fungi are the bad guys. Today I'm going to be talking about the fungi probably more as the good guys, and we should be thinking about them more. This here is a fungus called Antrodia that was rotting some wood in my wood pile in my backyard. Very important function of fungi is to rot wood. Okay, so to orient you about fungi, because I am the first speaker today, I'm going to maybe be telling you for the first time what a fungus is. Probably some of you are already enlightened about fungi, but when we think about fungi, we think about mushrooms, we think about lichens. These are the crusty organisms that grow on trees that are actually a symbiosis between a fungus and an alga. We also think about mold, which you can see molding that bread down in the corner. And also the sponsor of this evening, the yeast that brewed the beer in the other corner there. Yes, you can give a hand to the yeast that brewed the beer. When I think about fungi, however, I think about the way they are most of the time in their existence, which is as these, well, one of two forms really. They're either these threads that sort of live in their food and they live in other organisms. And they just sort of creep around inside of things. They live in their food and they secrete enzymes and they absorb stuff from the environment, and that's how they live. Or alternatively, they can be like that little bit in the corner there, these little single cellular yeasts. But they also tend to live inside of things and in plants and that sort of thing. They have lots of different roles that they play in the environment. I'm going to be showing you just a few today, how they are associated with plants. Guillermo, who's going to follow me, is going to talk about some more striking examples of how they associate with insects. So there are about 2 to 4 million species of fungi estimated, and about 90% of those, actually, we haven't seen them yet, close enough to really decide, are they new species? About 2 to 4 million. To put that in context, we have about 650,000 plants species and about 1 to 2 million animal species on Earth. So there's a ton of species of fungi. And the way that this is estimated is we think that there's about, for every plant species, there's about 6 species of fungi. And that sort of makes a lot of sense when you think about the ways that fungi are intimately associated with plants. So if you can see this picture, maybe you can't if you're way out in the back there. What this is showing is a tree leaf, a poplar tree leaf. And the things that look like 2 bananas hugging, those are little pores in the bottom of the leaf that let gas inside, let the leaf breathe. And what the blue thread that runs across the screen is a fungus. It's been stained so that you can see it. It climbs in through the hole in the leaf, and then it just, without causing any harm, it finds a way to grow and live inside of that leaf. And these are called endophytes, endophytic fungi. And they can do a lot of different things that actually benefit the plant. They can increase the plant's immune system. They can fight off other pests and predators without causing any harm on their own. And when the leaf falls in the autumn, they can actually digest the leaf and it becomes part of the soil. So they're intimately involved in the life of this plant. Here's another fungus type that associates with 90% of plant species roots. 90% of all the plants that you see around you, from the grass to the trees over there, have this kind or a similar kind of fungus on their roots. What's it doing? Well, If you look on the left side there, you see a mushroom right next to a little tiny pine tree. And then down in the test tube below, you see where the action is happening. There's a fungus has wrapped itself around the roots of this little baby pine tree, and the fungus is acquiring nutrients from the soil and giving them to the plant, and the plant is giving back sugar. And it's this mutualistic relationship we call mycorrhizae. If you look in the upper right, that's what they look like when you dig them up from the soil. If you find tree root tips under the soil, you're really looking at fungus most of the time. And this is a picture of that intimate association where the fungus just gets in the root cell, gets around the root cells, and has a very close exchange of nutrients with the plant. 90% of plants have these symbioses. Here's something that you might not think of necessarily as a symbiosis, but it's a really critical association that plants and fungi have. It's heart rot. So as a tree gets older, over 40 or 50 years old, the heartwood on the inside of the stem and the inside of the trunk is dead. And through wounds, fungi can get in there, mushroom-forming fungi can get in there, and they can digest all that heart of the tree and leave it hollow and leave the tree a lot lighter and a lot more resistant to it getting blown over sometimes. Sometimes it can be more of a problem. Sometimes it can weaken the tree and get it to fall, but that's not the important part of this relationship. What's important here is that these holes in the tree are providing critical habitat for about 30% of the bird and mammal species that live in the forest. So these are essential homes and roosts for the animals in the forest, critical part of the biodiversity. And here's what they're doing inside of there. They're digesting wood. Well, fungi are actually just one specific group of fungi, the only living things that can use enzymes to digest wood. If we didn't have that one group of fungi, we'd be drowning in wood right now. So this is them. This is one of those fungi getting in and around that wood and turning it into nothing. That takes some pretty amazing enzymes. Those enzymes, they're pretty radical. They throw out radicals. Actually, they're called oxygen radicals, and they break up that wood and that some really tough chemicals that hold that wood rigid and strong. And those same enzymes are what makes these same fungi able to break down really nasty toxins that we drop into the environment, like petroleum and pesticides. They can use those same enzymes to break those things down, and consequently, they become really good agents for what we call mycoremediation, cleaning up the environment using fungi. So it's usually those wood-rotting fungi that we use to break down petroleum spills or clean up other contaminants in the environment. And here's Paul Stamets pouring some oil onto some oyster mushroom mycelium, and the oyster mushroom springs up in a few weeks. So that's some intimate association between the fungi and the plants that have benefits for the animals in the forest, but these fungi have also been interacting with people for a long time. And the different species of mushroom are a very important part of the cultural cuisine of indigenous people around the world, and other cultures around the world find mushrooms very important to their cuisine. And if you look in the upper right corner, some fungi are very important to our medicines. So penicillin comes from penicillium. It was the first antibiotic. And fungi like this are very important sources of novel pharmaceuticals. The fungus down in the lower right is a pharmaceutical that's been used for thousands of years in a spiritual and medicinal context, and may have new roles in addressing the mental health and addiction situation, and that is psilocybe, which produces psilocybin. So from a conservation perspective, we think about all these relationships that fungi have. You would think, wow, these are really important. We should be really paying attention to them. They're essential to the functioning of forests. Those mycorrhizae connect trees to trees and help the forest stay together. We call it the wood wide web. So we must really be keeping real tabs on how well the fungi are doing. But for the most part, fungi have been ignored. The International Union for the Conservation of Nature and Natural Resources runs a red list for threatened and endangered species to keep an eye on species that might be at risk in the environment. And they do assessments. And as of 2021, they have investigated 54,000 animals and determined their endangered or critical status. Plants, 54,000 as well. Oh, I think I put the wrong number for plants in there. Sorry about that. I have an error in my slide. It's a similar number. However, for fungi, we only have 425. So 2 to 4 million species, we've only really evaluated whether 425 of them are in any danger of extinction. And in fact, environmental laws that take control of endangered animals and endangered plants, for all but one country on Earth, they do not include fungi in their environmental assessments that have to be considered for environmental impact. That country is Chile, and that's thanks to a non-governmental organization in Chile called the Fungi Foundation, which hopefully you could be aware of, that is running a fight to get fungi recognized for their importance to biodiversity. So is it really something that we should be concerned about? Do we have to be looking out for fungi? I mean, they just spring up. They're mold. In fact, they show up when we don't even want them. They mold our food in our refrigerator. We don't really need to care yet, right? Well, actually, maybe fungi are threatened by some of the current situations we have going on now. Monocultures. If you look on the left, that's a typical Google Maps view of the Midwest of the United States. Very few species of plants, and the fewer species of plants, you have 6 species of fungi for every species of plant, means that there are few fungal species can live in that environment. Managed forests. We have trees that are cut before they can get heart rot, that make little holes for the animals in the forest to live. They can only grow up to be about 30 years old, and then they're cut and harvested for timber. And then the wood decay fungi that would live on the ground, well, they clean up the wood on the ground in the managed forest, so there's none of those environmental niches. So in a managed forest, there's not really a place for fungi either. And then there's the atmosphere. We have power generators, motor vehicles, and agriculture puts a lot of nutrients in the form of nitrogen and sulfur into the air, and it comes down in the rain. And that lands in the ecosystems where the fungi live, and what does that do? Well, if you remember from earlier on in the talk, the nitrogen is, from the nutrition of the nitrogen, is what the fungus was giving to the plant in exchange for the sugar that the plant was providing for the fungus. Well, when the atmosphere provides that nitrogen in excess, then the plant stops giving as much sugar to the fungi on their roots. So the fungi tend to lose their homes on the roots of the plants. So the more nitrogen deposition, the fewer fungal species we have. So are fungi threatened? Well, where we're starting to see mostly different species of fungi become endangered, it's where the old growth forests are being lost due to fire and clearing. For instance, we have this Brygioporus nobilissimus. This is a large fungus that grows on fir trees. It's like That mushroom there is about 1 meter across. It has about, it can have 100 layers of pores, meaning that the mushroom regenerated itself year after year after year. These are really long-lived. And there's very few of them left because there's not these large, hundreds of years old fir trees that they prefer to live on. There's also truffles. Truffles live in environments that are being built up for housing on the West Coast. And these truffles here, Distuncia rubra here, it could very well be a favored food for some little mammals that live in those Pacific Northwest forests as well. So it's all tied together, and I'll end with the question, should we be watching over the fungi? Is this something we need to be caring about for wildlife, for the people, and for the environment? And that's all.